We're going to open our WSA series with a discussion on Hypertext Transfer Protocol, HTTP. HTTP is the most commonly used application layer protocol in the world. The protocol is stateless and text-based. It follows the request-response model. So there is going to be a client. This is going to be our browser. This application is going to request content of a web page, which is going to be hosted by a server. And server is going to deliver the page content with the ADO response messages. Now, a single exchange of HTTP information, a request and response, this is what we call a transaction. A single exchange of messages between a client and a server. Now, because of the fact that in most cases there is going to be more than one transaction that will happen between a client and a server to download the content of a website, we will also have a concept of a HTTP session, which can be described as a collection of all individual transactions performed to download the website's content. For instance, first transaction is going to be used to download the index of the website, index.html, which is more of like a description of the website. Then a second transaction may be used to authenticate the user. And finally, third transaction is going to be used to download the content, like images, like video files, and so on. So all those transactions together, they make up a single HTTP session. Okay, and now the problem with HTTP in general is that the protocol is completely stateless. A server has no way to remember about the information that was previously exchanged with its clients. Like in our case, when a client authenticates to a server using this second transaction, this information is normally not stored, is not remembered by a client or a server. So the server says, yes, you are authenticated, but it forgets about the request. And when a client tries to download the content of the website, the server is going to prompt the client for authentication once again. So this is what happens normally without an additional mechanisms added kind of like on top of HTTP to exchange the state information. And this is exactly where the concept of HTTP cookies comes into play. So with cookies, the concept is going to be all about maintaining certain information between a client and a server. Like when our client sends a request, let's say to authenticate with a server, and the server replies back saying that authentication was successful. With the cookie mechanism in place, the server is also going to include the cookie in one of the HTTP response headers, which cookie is going to be then used by our client in subsequent requests. So this cookie here and this one here is going to be the same. Now, what information is going to be stored inside of the cookie will eventually depend on the application. Like in our case, there's going to be authentication credentials. So anytime a client sends a new request to the server, it is going to include its credentials and authentication state inside of those cookie messages. And those cookies can be persistent, like when the client writes them on the disk, or they might be session specific, in which case they are only maintained in the memory and are deleted when the user closes the browser. The default port number allocated by IANA for HTTP is obviously 80, and this is what you will use for clear text HTTP communication. We've got several versions of HTTP. The most current one is version 2, but it is still not widely adopted. Most transactions that happen now they will use depend on version 1.1. Okay, the main benefit of version 2 is gonna be speed. This is why we will eventually shift towards this version. Where in case of the previous versions, The main difference like between 1.1 and let's say version 09 or 1.0 was the amount of TCP sessions used for an HTTP session. So with version 0.9 and 1.0, we had to build a separate TCP session for every single transaction. Like when you had, let's say, 4 transactions within a single HTTP session, you had to build 4 TCP sessions, one for each of those transactions. With version 1.1, this changes because we have a concept of persistent sessions, which allows us to use just one TCP session to perform all transactions within a single HTTP session. And this is, of course, also used by version 2 of HTTP. Just one TCP session is needed to deliver the entire content of a website to the client. As I said previously, our clients and servers, they will exchange the HTTP information using HTTP messages. So we will now take a look at generic structure of a HTTP message, like what type of fields and elements are going to be used, exchanged between the clients and the servers. So the message is going to start with a line, request or a status line. Like the request line, this is what you will see in client messages versus the status line, and this is what we will see in messages sent by the servers. Now, the status line is sometimes also known as the response line. And we'll get back to the concept of the request/status line in just a moment. What is gonna follow next is gonna be a bunch of headers, like request or response headers, depending on what type of message we are dealing with. Then we will see an empty line, and finally the packet is gonna end with a body. Like in case of the response, it is gonna be the content of the web page. And now in terms of the details, we are gonna start with the request messages generated by the clients, in which case the request line is gonna take a form of a method, URI, and a version. Like an example that we have here, get is making our method, which is more of like an action. This is what we use to tell the server what do we want to do with our resource, which is the URI. Like for example, what file I want to download. And of course the version is how we signal to the server which HTTP version we want to use for the session. Okay, the next portion of the HTTP request message is gonna consist of a bunch of request headers. There are actually multiple headers that can show up depending on the type of the request, depending on what type of resource we want to download. But the most important of the headers is gonna be known as a host header. So the host header, this is what defines the server that we want to connect to. Like when you open up a browser and say that you want to go to www.cisco.com, this information is going to be stored inside of the host header. So this is what makes my host. Okay, now this portion is what makes the URI. So the host and URI, this is what is going to make our URL. Now, technically, this is not 100% correct. This is more of like a simplified definition of a URL, because technically speaking, URL is just one of the URI types. But in case of web requests, the information about the resource is separated from the information about the location of that resource. So for simplicity, we can say that the URL that we type into a browser is broken down into these two fields. We've got the host header, which identifies the server we want to connect to, and we've got the URI, what identifies a file, a resource that we want to possibly download, like in this case with the GET method. Similar to HTTP headers, there are actually multiple HTTP methods that can be used by a client to tell the server what we want to do, what action we want to perform on a resource. So GET, this is the most common method. This is how you tell the server that you not only want to download the headers, but also the content of the website. Now you can also use the head method, which is how you tell the server that you would like to get the response headers, but without a content. So this is going to be useful like when the browser is trying to determine, for example, a size of a file. So it doesn't really want to download it now, it just wants to see what's stored on the server and how it looks. And we also have the push method, which is how you would normally upload files to a server. Now, in case of the server messages, so our HTTP responses, those will start with a status line. This is our equivalent of request lines on the client messages. As you can see, the structure is slightly different because we start with a version that is supported by the server. And then there is going to be a code, which is more of like a result that is supposed to tell the client if the request was successfully processed or maybe there is some sort of a problem. We will take a look at individual codes categories later in this session. And there is also going to be the reason, which is just a description, human readable text to tell exactly what was the problem or maybe anything else that the server wants to tell the client. Like with requests, there are going to be potentially multiple response headers that will follow the status line. We will then see an empty line and finally a body, the content of the message. The code portion of the response message consists of 3 digits. It uses that 3-digit format. And in reality, the most important of those 3 digits is going to be the first one. The first digit is going to describe a category of the response. The remaining digits, they will be used to point to a more accurate, detailed information about a particular response. So whenever your browser gets a response with a code of 1, it means that it is some sort of an informational message. Now, whenever we see a message starting with 2, this means that the client request was successfully processed. So those messages will also normally deliver the actual content of the website. And next, we've got 3, which implies redirection. That type of response also contains the location header, which includes URL we want the client to connect to. So this is going to be a new URL that the client is supposed to use for a session. So that type of messages, we can commonly see them with certain features enabled on our security appliances. Like in case of WSA, you would see those responses for sessions that are to be authenticated on the proxy. Like the WSA is going to tell the client to connect to its own interface, to its own data port, so that the client can authenticate. It is also going to be the identity services engine what will use that type of messages. Number 4, this one is all about client-side errors, like the request was improperly formed. Maybe there was a problem with syntax, or maybe you simply used Telnet to emulate a web request and you didn't follow the RFC in terms of the syntax structure. And number 5 implies a problem, but this time located on the server itself. Maybe server doesn't have enough resources to process the request. It is going to reply with a code starting with 5. And this is what you would also normally see being displayed in the browser, along with a description of the problem. The main problem with HTTP, especially these days, is that its transactions are always exchanging clear text. HTTP itself does not offer any type of encryption authentication services, and because of that, a more secure version of the protocol was created, known as HTTPS, HTTP Secure. Now, technically speaking, HTTPS is actually not a new protocol. It is a combination of HTTP and SSL or TLS. So we know that SSL TLS, this is a session layer, a protocol that allows us to secure other protocols by re-encapsulating original messages with its own headers. And this is exactly what is also going to happen in case of HTTP. HTTPS is essentially HTTP encapsulated into SSL or TLS. Now, in order to distinguish between clear text and encrypted communication, HTTPS URLs, they will always start with HTTPS instead of HTTP. And there's also going to be a new port number, what's allocated for that type of communication, TCP port 443. In terms of the level of protection that is offered by HTTPS, it is a very secure approach since the encryption and integrity checks are applied to the entire HTTP packet, including request or response lines, headers, and the body. So it's not just the body, not just the content of the website was encrypted, but also the URL and the address inside of the host header.